During the 1970s, the world's early planners of direct-to-broadcast satellites thought that 3 to 5 channels of television would be more than sufficient to meet consumer demand. But once millions of American households began receiving dozens of channels using big C-band dishes, the game was over.
And it's very interesting to me that C-band has really taught us and taught the world a lesson. And that lesson is that all of the old planning for 3 to 5 channels of television was simply baloney. People won't buy 3 to 5 channels of television because they've had the experience now with cable, where they get 30 to 60 channels. They've had the experience with C-band, where we at times have 200 channels of video. That's what people see and that's what people want.
In 1988, the International Standards Organization, which operates under the auspices of the International Telecommunication Union of the United Nations, established a technical committee known as the Moving Pictures Experts Group. The MPEG committee's task was to create an internationally recognized worldwide standard for the compressed representation of multimedia. The MPEG committee initially developed a standard for a wide variety of non-interlace or progressive scan sources of multimedia, including text, graphics, photos, audio, and motion pictures. Video sequences are highly correlated in time, with each frame in a sequence quite similar to both the preceding and following frames. It is therefore unnecessary to resend the parts of the image in which no elements have changed. The basic unit used for motion compensated prediction is called a macro block. A macro block consists of 4 8x8 blocks of pixels containing the luminance or brightness data and 2 corresponding 8x8 blocks of chrominance or color data. The encoder economizes on bandwidth by instructing the receiver to recall a previous frame's unchanged macro blocks from a buffer storage circuit and reinsert them into one or more subsequent frames. This requires substantially less information or bandwidth than sending all frames in their entirety. Motion compensation is used to compute the direction and speed of moving objects within the video image. All macro blocks are scanned to identify those portions which will not change position. Predictor blocks also are identified, with their position and direction of motion noted. Only the relatively small difference, called the motion compensation residual, between each predictor block and the affected current block is sent to the receiver. If all of these differences are communicated directly to the receiver, then no distortions or artifacts will be visible in the displayed image. Artifacts will be introduced whenever there is an insufficient number of bits available to communicate essential image information and rapid motion changes from one frame to the next. In this case, it is a trade-off between bit rate and image fidelity. MPEG accurately predicts where a moving object should appear in each succeeding frame using a very small number of bits. Moving, yet relatively unchanging objects are reduced to a mathematical shorthand equivalent of take the same object from the initial frame and move it 3 macro blocks to screen right for the next frame. Objects which change shape and move at the same time, or multiple objects which are moving in different directions at different rates, do not compress as easily. These objects therefore require a larger assignment of capacity in the bit stream. Whenever major scene changes occur, the encoder must instruct the receiver to dump the blocks from the previous frame stored in the receiver's frame buffer and transmit an entire set of new blocks. MPEG provides for 3 different types of video frames which can be coded into a digital bit stream. The first frame in any video segment is called an intraframe or I-frame. The I-frame is coded using only information presented within itself. No reference is made to other frames within the digital bit stream. I-frames occur on an average of 1 out of every 10 to 15 frames, or whenever there is a scene change. MPEG uses the I-frames as a reference for predicting 1 or more subsequent frames. P-frames are predicted frames with reference to information presented in the nearest preceding I or P frame. Each P-frame also serves as a reference for future P-frames. B-frames are bidirectional frames that are coded using motion-compensated prediction from the nearest preceding I or P frame and the nearest following I or P frame. The sum of the bits assigned to the I, P, and B frames cannot exceed the allocated transmission speed in any given second. Not all MPEG-2 systems use B-frames. Those systems which do employ B-frames achieve a more efficient level of compression by up to 15 to 20%. Less data, therefore, is needed to achieve the same video quality. Decoders using B-frames, however, must have a second frame buffer. This adds to the cost of the total system.
Compression is very much like what everybody's used to in Name That Tune. It's how many notes do you need to be able to tell what the song is. At 8 notes, most everyone can guess what the song is. But if you only have 1 or 2 notes, it's very difficult. If in the B-frame implementation, you only need the 1 or 2 notes to be able to accurately.
The MPEG-2 standard, also known as DVB, was specifically optimized for the transmission of both standard and high-definition television programs. With the rise of the Internet, however, the applications for digital video expanded dramatically. More efficient forms of compression were clearly required, with bit rates that could accommodate video conferencing and streaming multimedia to PCs. Moreover, the technology had to be fully compatible with both wireline and wireless networks. Last but not least, the worldwide switch to high-definition television forced the industry to push the compression envelope even further to accommodate HDTV's higher image resolution and 16:9 aspect ratio. Officially known as H.264 or MPEG-4 Part 10, the latest advanced digital coding is squarely built on many of the same tools and techniques to be found in MPEG-2. Satellite broadcasters like DirecTV are using it to transmit their programs in a high-definition format. To ensure interoperability between heterogeneous systems, Advanced Video Coding, or AVC for short, provides for 3 distinct profiles, each with its own unique set of compression tools. The baseline profile contains the simplest tool set of the 3. It is for use by decoders with the least intensive processing requirements, such as video over Internet Protocol or the streaming of TV to mobile handsets. It achieves a 1.5 times improvement in compression over MPEG-2. The extended profile is suitable for use in Internet-capable PCs and sophisticated handsets. It achieves a 2 times improvement in compression efficiency over MPEG-2. The most complex of the 3 is the main profile, which is really best suited for broadcasting applications, since it includes interlaced video tools. It achieves a 3 times improvement in compression efficiency over MPEG-2.